Well, hello again. I've been making tadpole tilting trikes for some time. Every time I build one and test it, I just want to make a new one, improving all the things that aren't great. And I share everything with you. The drawings, the ideas, the tests, and I take valuable advice from your comments. Thank you for that. This time I decided to do some fundamental changes to the design to achieve the improvements that are necessary, such as increasing the amount of tilting that the trike can do. I also changed how the wishbones are supported to the frame and some other things. Because there are so many changes, I decided to make a full assembly with some 3D printed parts so that I could test the design, share it with you and get some valuable advice before I commit to fabricating the metal parts. There is something special in this video. I will actually show the roll center of the vehicle. I've seen many YouTube videos with great explanations about roll center, but I've never seen one where they actually show you on the actual vehicle the roll center. So I think there's a little bit of value added to the internet here. Okay, I'll show the new design choices, how it's built, how it works, what's better and worse. Let's go. In the last version, the trike could only tilt about 12 degrees. So in this new version, I designed the knuckles to accommodate another type of ball joints and install them with all the vertical freedom. These are the components that will make the knuckle. Let's put them together. Now let's work on the axle. I'm using a lefty hub and the axle broke last time. I got advice from viewers to make a hole in it and use a steel axle inside, and that's what I'll do. And this is where I learned that the bracket that I designed is only valid for the right wheel. And of course that's because bicycles have the disc brake on the left. So yeah, I'm gonna redesign that and use one bracket for the right wheel and design a different one for the left wheel. That works. This project is being made with the support of PCBWay. They offer a wide range of manufacturing services such as 3D printing, and even though these were made at home, I have used their services multiple times for things that I cannot make, such as CNC machining, steel sheet laser cutting, PCB manufacturing and assembly. They are awesome. Please check the link to their website in the description. It's their anniversary and they have a bunch of cool offers. And now let's make the wishbones. And the center brackets. This is it. All assembled. Oh. I hope it goes in. All right, I've seen this before. Let's hope for the best. Product placement. See. Yes, that happened. Everything broke with this weak design and 15% infill, so I printed 100% with a more sturdy design and go all over again. And I also made the shock brackets in metal and a little bit higher because the shock was interfering with the center bracket. The tilting mechanism can tilt more or less 30 degrees, and this is the component that limits its tilting. This is probably the right place to install a limit for the tilting. The upper knuckle bracket works as designed with about 30 degrees of turn to each side. And the bottom bracket of the knuckle interferes there when it's turning, and the more it's tilted, the more it interferes and the less it can turn. And when I install the steering arm with this type of ball joints, now the tilting is limited by the steering ball joints. So I decided to try to use one of these universal joints, that's how I think they're called, on one side, just like that. I got this idea from one of my favorite trikes out there, the Bowhead Rogue. That's how they show it in their maintenance manual video. Though I don't know how to secure my rod to this, it doesn't have any fixing, but then I just welded two nuts to it. Let's try that then. Just install it like the bowhead rogue with the ball joint on one side and that kind of linkage on the knuckle. The steering seems to work well. But the tilting is still limited by that ball joint. I mean, it doesn't matter if I put a linkage on one side that can go to any angle, when the linkage on the other side, the ball joint, cannot go more than almost 30 degrees, so I'm still limited by that ball joint. But I'll think about that later. Let's assemble the rest now. See that wheel going up when turning? That's what the kingpin inclination does, causing a straightening effect to the vehicle. And I managed to remove the supports without breaking everything, so here's a look around.
Bye.
So the last version could only tilt to up to 12 degrees, so this is already an improvement. And this is, I think, a very cool demonstration of the roll center, which is a very important design aspect of a vehicle. The roll center is the part that does not move when you're rolling. I took this bit from one of my favorite videos that explains roll center on a vehicle. Please find the link in the description if you're interested. And usually the roll center is a little bit above ground and the center of gravity is a little bit above that. For my design, I wanted the roll center to be at the ground level because that's how a bike works. And I want this to behave as much like a bike, so I designed it to have roll center at the ground level. Alright, I just need to fix a few things before I make the metal parts. One, when it tilts, I don't want the ball joint to hit this part here, so it will have some bump stops, but also I'm considering changing this part to make it tilt a little bit more. Second, when it turns and it's tilted, it hits the sides of this ball joint here, so I have to change this somehow to let it turn as much when it's tilted or not. And the last but not least, the steering connection has to allow for as much inclination as the tilting mechanism. So now these ball joints of the steering are limiting the tilting actually. So I think maybe the solution is to use on both sides the universal joints. I'll put one on each side to test. Let me know if you have a good idea about that. and then I can make everything in metal and go for a ride.